Today we're going to talk about scatter plots. Well, what is a scatter plot? Well, I know to scatter means to throw things around, and plot in math terms is to put points on a coordinate grid. So a scatter plot is showing a relationship between those two variables on a coordinate grid. We can have positive correlations, no correlations, or negative correlations. You can see here I'm going to be plotting those points of the amount of sugar people put in their cups. Sugar is my Y value and age in years is my X value. And I can see here that as people get older, they use less sugar in their cups. And I've drawn in a trend line that shows me that I have a negative relationship. I can see that I have all kinds of different relationships. I can have a weak positive relationship. I can have a strong positive relationship, showing that the points are getting very, very close together. Weak negative or strong negative. Again, the difference is one has the dots more spread out, and the other has the dots more evenly spaced closer together. And then I can have no correlation whatsoever. A trend line that I talked about is a line that approximates the relationship, and I can put it in the middle of my set of data. And I can use that trend line and write the equation of that trend line to make predictions about what is going to happen next. Let's look at these four scatter plots. Scatter plot A has a negative correlation. I can see as X is getting larger that Y is getting smaller. B, as X grows in value, Y also grows in value. C, looks like the points are all over the place. And D, boy, that is a tight relationship, and as X gets larger, so does Y. Now let's look at the choices. 1, X is the number of apples bought, and Y is the total cost of the apples. 2, the distance from a country to its equator and the yearly average temperature. 3, the height of people and the weight of people. And 4, the distance student travels to school and the color of their pets. All right, so let's look at this. The number of apples bought by customers. Well, I know if I keep buying more and more apples, my price is going to get higher and higher. So if I buy 1 apple, it's going to be one price. 2 apples, another price. 3 apples, another price. I think it has to be D. The distance a country is to an equator means that if the closer I get to the equator, the hotter it's going to be. That means the temperature is going to be higher. And the further away I get from the equator, then the colder it's going to be and the lower my temperature is going to be. That must be A. As people get taller, I'm assuming that they're going to start weighing more. So that has to be B. And there is no correlation whatsoever in the distance I go to school and the color of my pet, meaning it has to be C. The scatter plot on the right shows the mean sea level on different months from 1993 to 2011. Which statement best described the mean sea level and the year shown on the scatter plot? So I'm looking there, and wow, there's a lot of points on that scatter plot. A, as the year increases, the mean sea level also increases. Well, kind of looks that way. As the year increases, the mean sea level decreases. No, it can't be B. As the year increases, the mean sea level keeps constant. No, because that would be a straight line. As the sea level increases, the year increases. Yep, it has to be A. Chang wants to know if he's improving his skill on the cello. He created a scatter plot and drew a line of best fit. So if he uses those 2 points that he's given, what is going to be that equation? Well, I know that I can find the slope of that line. So I can do that by taking the change in y over the change in x. When I do that, I get about a negative 2.16 repeating. Then if I plug that into the equation of a line, y equals mx plus b, and solve for b, I can find that b equals 12.3. A baseball coach graphs some data and finds the line of best fit. The equation for the line of best fit is y equals 0.32x minus 20.51, where x is the number of times at bat and y is the number of hits. Well, I know that they've given me the equation. I know now my question asks, how many hits should he expect from a player who is at bat 175 times? Well, x is the times at bat. That means I need to plug and chug. Put in 175 in for x and find out that the answer is 35 hits.